Hello everyone, I am Tausif Babu from Electronics and Communication Department, PIET, Parul University. Today we have expert from field of wireless communication, Mr. Ashwin Shukla, who is serving on post of manager at Samsung India Electronics Private Limited. He had passed his bachelor degree in field of electronics and communication engineering from Bhavnagar University in 2009. He is expert in Manson field from his college level. From 2009 to till date, he has experience of working in wireless communication field in various companies. I thankful him for giving time from his busy schedules. Now, without wasting time, I welcome Mr. Ashwin Shukla and like to invite him for conducting next session of today's webinar. Now, please, Mr. Ashwin.
Yeah, so thank you, Mr. Tausif and entire Parul University team for giving me this opportunity to share my thoughts, my ideas, and we have a quite fruitful discussion, I hope so, in this session. So before beginning to the today's agenda, I wanted to have a brief introduction of my professional career. So I have started my professional journey since 2010 uh, in communication field only, and in 11 years of experience, I have worked in different companies in different capacities. In that, I have worked as a network planning engineer to product solution manager to currently working as a solution sales and services. So there it is a quite good remarkable journey in a field of communication where I have started my journey from Nokia Siemens Networks to Airtel, Bharti Airtel Limited, and then moving forward, I served in Ericsson India Global Services Private Limited, and last 4.5 years, I'm serving in Samsung India Electronics Private Limited in solution sales and services department, where I am majorly responsible for the solutions for the customer requirements, flexible customer requirements, and also for the business development. So that is the brief introduction from my side. I think before wasting much time, we should start our agenda of today of wireless broadband, its future and beyond. So I'm sharing my screen. If anyone has an issue with screen, please do let me or know or raise your hand. I hope this first slide is visible to all of us and all our participants. Tausif, is it visible?
Yes, Ashwin, it's visible clearly.
Okay, thanks. So today's agenda, we will try to cover several topics that includes my introduction that we have just finished, and the synopsis of Indian mobile telecom industry, then the brief history of first generation of mobile communication to the current and the much talked 5G technology, and then what is the broadband, how the broadband facilities can be provided, and majorly we will talk about the 4G and its previous generation technology 4G also, and with comparison to 5G, and then we will slowly and steadily move to 5G use cases and network functionality. Meantime, some of the topics I have not mentioned here, but if it will come to in my mind and it is worth sharing, I will try to share it as per my limited capacity. So, about today's Indian telecom market. So, as we are speaking, we are currently in a second quarter of 2021, and uh, these are the some of the data that is available on different government portals as well as on Google as well. that by Q1 of 2021, more than 650 million smartphone users has been accounted in Indian telecom markets, and the average internet penetration in pan India it is around 45%. And by December 2020, average monthly consumption of data is around 13.5 GB per person. So we can assume how much data every Indian is consuming nowadays, and for that capacity requirement, how should our the network should be, and how robust our entire ecosystem should be. So as we are talking right now, so majority there are four operators in India right now. Three are private sectors and one is public sector. And I think all of you are aware of that. That are Reliance Jio Infocom, Bharti Airtel Limited, and Vodafone Idea. These three are the private operators, and BSNL is the one public service operator. And if we talk about the entire telecom market and its data contribution in a global industry, so as of Q2 of this year, it was reported in by DOT that 25,227 petabytes, this much of data traffic is generated by our India, and it is nevertheless second largest data contributing market. So that is how Indian telecom market is growing up, and you can assume 25,227 petabytes. So almost one petabytes is 10 to power 6 terabytes. So you can assume how much gigabytes it should. You can just assume that. Uh, as of last year, calendar year finish, 1,173 million customer has been reported by Department of Telecommunication of India, and that is including all the subscribers, whether those are the mobile communication subscriber, or either fixed broadband, or it is a telephone, or it is a cable, or anything. It is an entire communication subscriber. And before going the superficial observatory 5G discussion, also I want to mention some major mobile gear vendors or OEM that stand for original equipment manufacturer. So some of you might be aware that operators basically using the Samsung mobile gear vendors or OEMs for their network service provider or their equipments they are using. So some of the major names I have mentioned here. So students who are graduating or who are yet to graduate, they should be aware who are the main players in the telecom industries in equipment side or gear vendor side. So some of the major vendors are Samsung, Ericsson, Nokia, Cisco, Mavenir, Huawei, ZTE, Ciena, NEC, Ceragon, Siemens. So these are very big names in the telecom industry or in a sector of gear making for telecommunication equipment. Some of these are the baseband unit, or what in general term we are calling a Node B or eNode B provider. Some of them are the other equipment providers like routers, switches, or service switching centers, or microwave or optical fiber communication devices. So just for your information, I thought it is worth to say. So anyone have an idea what is the broadband according to our 1996 telecom policy in India? What is the definition, or what are the data rates uh, Indian telecom market had expected in the terms of broadband? So let me give you a brief idea. In 1996 telecom policy, it was stated that 256 kbps or more than that line speed can be considered as a broadband, and then eventually it was modified in 2004 National Telecom Policy, and that barrier has been increased from 256 kbps to 2.048 mbps. That is, in general terms, we call it 2 mbps line. So as of now, the general broadband line rate is considered as a 2 mbps. And also, I will give you some idea about how we have reached from the our ancestor technology that we have started from first generation of wireless communication to currently serving fifth generation of wireless network. That in 1G in full duplex mode, we were able to achieve from 2.4 kbps, and it was in initial 1980s where we have started, and we have achieved 2.4 kbps, and basically it was for voice purpose and paging related things only. Slowly things requirements got changed, market dynamics also got changed, and we switched to second generation of technology where also the basic idea was for the better quality of voice, and along with the voice telegraphy and some other messages service was also required. So in that case we were able to achieve 64 kbps, and then 3G where uh, HSPDA and HSUPA technologies as introduced in India. I think it was a 2008-9 period. It was introduced, but in a global level, it was 3G almost 2000 or 2001. It was introduced. So we were quite late in that scenario. So in 3G, we were from 144 kbps to 2 mbps, or in video requirement, if there is not much load on this network, then we were able to achieve up to 5 mbps also. Somehow that technology didn't work quite well in Indian telecom market, and also in a global level also the demand for other generations and video gaming videos and other real timing applications demands came out in a drastic manner. So eventually 4G has developed, and the initial target for the 4G was from IMT. IMT stand for International Mobile Telecommunication. 2000 it is called, and it is the subsidiary body of ITU, which basically defined the standards and standardized protocol and making the standard uh, protocols or standard interoperability between different vendors or requirements of the market, and that is applicable throughout the globe. So in 4G, the aim was from achieve 100 mbps to 1 gbps. That was the theoretical idea or on paper idea. In lab condition, some of the gear vendors and some of the OEMs were able to achieve this speed, but in general scenario, that is yet beyond our reach till now. Yes, peak rate we have achieved up to 400 mbps or something in India, but in a average speed, or you can say a user data speed, it is yet to achieve. And moving to 5G, so since last 2 years, 3 years, uh, we are having much talk about 5G. When the 5G come, what is the need of 5G, and how the 5G will be different and other. So rough idea of 5G is that any speed that we can achieve from 1 gbps to 20 gbps or beyond that, that will be the standard 5G fifth generation wireless network. And also the recommendation is the average speed for the user should be 50 mbps if he or she is connected to a 5G ecosystem. Also, I will talk about some old technologies which were previously used in a broadband, and some of the industries also right now also it is being used. Like you might have heard about the DSL, the digital subscriber line, or some people also call it as a lease line, where industry or some people who are, or some home or offices who have a dedicated link requirement from their office business purposes. So operators are giving these lease line services through whether a copper media or fiber media. It is basis on the network they are having in that particular location. One interesting thing also came over while studying this broadband, that broadband over power line. This was also the conceptual idea, but I am not aware of any such. At least in India, I am not aware of any such technology right now operating in India. It might be out of India. It would be somewhere else. But theoretically, it was also a concept to provide the internet over a power line, like our or electricity providing company. So from that wires and other also we can get the internet. Yeah. So uh, in this slide we will discuss what are the main facilitator to provide us the broadband. So broadband is basically any high speed internet access available to us through any medium of communication, whether it is a optical fiber or it is a point to point microwave, and that is also called IWAN link, Internet Wide Area Network. So some of you guys might have seen the synced tower, long towers, and one parabolic antenna on that. So that is basically a IWAN link. And then also some of the cable TV network also providing since last few years, 3 or 4 years, as I'm aware, like DAN network or GTPL in Gujarat. They are also the broadband provider through their existing infrastructure of cable or fiber optic network. Then, of course, wireless mobile communication, which covers all uh, the previous technologies, 2G, 3G, 4G, or currently it is 5G. And then your local ISP, like Ticona or anyone, I can name it, like Smart Broadband or some other companies are there who are serving as a local internet service provider. So basically, these we can have an internet connection that is having a speed more than 2 Mbps through any of these medium or through any of this way of communication. That is fall in the category of broadband. In my previous slide also I have discussed just to give the overlapping of the technology and how it is over the period, how it evolved from 1G to 5G. So as you can see in this slide, basic aim was up to 2G, it was a voice or SMS or messaging service. So data was not much of concern, but as the market and industry and the time has elapsed and people felt industry or normal people also, as the technology expanded, people felt that more demand of data. Then edge, then 3G. So edge and 3G, edge basically some of people calling it as a 2.75G also, where up to 356 kbps on a mobile network we were able to achieve. So in that also some of the data services was available, like we can play low resolution YouTube videos or other tube videos, or we can visit some sites where low resolution pixels are supported. But on a higher data segment, 2.75G was not sufficient. So initially, industry moved to 3G, but 3G was not also successful because of some industry segment, and also due to it's quite some features like CSFB fallback, because it was neither entirely based on the packet switch network, neither it was completely dependent on its previous ancestor technology like circuit switch network. So it was a hybrid network. So that is one thought it couldn't succeeded so much. And meantime, the 3G was not much matured, and we had a lot of talk, and globally 4G was coming. So 4G and 5G, that is completely a data oriented technology. And even voice initially in India, it was in a policy matter, which is, of course, it is decided by the government that in 4G also voice will be on a circuit switch network and data will go on a packet switch network. But over the period, people understood that it will be a most costlier and more complex uh, than to switch on the entire data network, and they have switched to the entire data network. And right now most of you using a Airtel, Vi or Jio's network. So Jio is fully voice over LT. So basically it is a technique of voice packets uh, sending over the IP network, and some other operators till also using CSFB. But as per my knowledge, majority of they have also switched over to voice over LT, and some part of country where yet, because you know there is some infrastructure challenges and capex and other related issues also. So well, there are still on circuit switch network. When you want to call somebody, then your network move on to the lower level of technology which is served in that cell or in that communication area, that is whether available 2G or 3G. For data, you are, of course, you are connected on a 4G only. 5G also, of course, if 4G is a completely data oriented, then 5G is also completely data oriented, and it is much beyond that. One common questions arise. We have a 4G and it is already a completely data centric technology. Then why we need 5G? So one basic thing is that till 3G or even you can say not the advanced version of 4G, LTE release 14 or till LTE release 12, uh, the main aim from the mobile communication or wireless broadband was to have a gaming video calls and basically connectivity, only a wireless connectivity for phones or some of the laptops and other things. Our customer premises like router or switches or dongles like that. The so 4G connectivity was limited to those customer premises equipment, whether it can be a phone, CPU, or router or dongle. But then eventually, industry expert had realized that as the technologies grows and we need to reach out our technology advancement in other areas as well, not only in the field of communication but in a automation, in a healthcare, in a robotics, or you can connect to any of the industry, food or agro or anything. So uh, there should be some robust system from which we can connect other industries, other domain also through our this wireless communication. So that is why 5G has evolved and in further enriched through different releases and these different ideas. Then second point is, of course, as uh, in our previous slide also, and you people are also aware that as the technology advancement is going on, so person or industry or anybody, the prime requirement speed and connectivity, whether it is in a data segment or it is a normal transport segment. We are so busy in our work or any of our tasks that we want to have to complete it as early as possible. We want to reach or we want to communicate as faster as possible. So that was also one reason for the evolvement of 5G. Then, of course, devices, because 4G has some limited connectivity where you can have a certain number of devices you can connect to one cell or one site. Suppose in one cell area, you can at a time you can cover around 256 users. So what is beyond that? And that 256 user is also all our mobile users or dongle user. So what for the others? So that is also one reason that there is a need of some technology which can have a n number of, theoretically tens of thousands of devices which can connect to the network. And then one more requirement, latency, and also students who are studying, they might have heard this word latency, or it is also commonly used as a delay. So this is the natural phenomena. We all are aware, and you guys are more expert on this phenomena than me. What causes the delays? So network topology, number of segments involved in the communication line, uh, then the technology using in a PCB. There are several things which are affecting the delays in the real network. So, if the latency is more, I mean delay is more. So some of the key things we have mentioned on above parts, like speed and connectivity, or for other industry, if delay is much, then we cannot operate successfully, or we cannot achieve our desired goal. If suppose, if I can give you an example, that if some doctor sitting in a London and he want to have a robotic surgery on a person who is having the patient of Apollo, or any hospital in a Baroda or any Ahmedabad or any metro city. And in India, or suppose in a hypothetical scenario, if you do not have a that expertise and we want to leverage on that person who is sitting in a London or USA or even in Delhi, and we want to do a real time operation basis on that. So if it is the previous technology, then delay is much more. So if some person is doing or going providing the some commands to do some operational part or some activity, then it might be reached to the person after several seconds of delay. And you are aware that we cannot afford in some fragile activity or some life saving activity, we cannot tolerate such kind of delay. So that was the one prime reason of having a very lower level of latency in the network, which we can have our meet our desired goal from the wireless communication. We will talk more about the latency because it is the key limiting factor in all wireless communication. So in upcoming slide, we will have a more discussion on that. In 4G, it is 4G sometimes also called EMBB, that means enhanced mobile broadband, and where the theoretical it was 50 to 100 Mbps should be achieved for average user, and on a peak in an entire cell basis it should be 10 Gbps. And one more point I have mentioned here, the backhaul option. So any wireless technology we are using or we are connected to the network, so there must be something in a backend, or sometimes it is also called as a front haul. So there must be some connectivity which is connecting us to the entire world. Or you can call it as a PDN, packet data network, or internet, whatever you want to call it. But there must have been some system. So that is called the backhaul or front haul. So we will cover that also. What are the backhaul technologies or front haul technologies? And last but not least, 5G is just not a mobile broadband or just a wireless communication for data or voice. It is much, much, much beyond that. It is creating a complete ecosystem, automated system, where machines can talk to each other, where uh, we can do so many things with the command level, or person and machine can interact. So it is an idea of equipping the entire system with, and having the all the wireless connectivity around us. So we can have a driverless car, or smart metering, or uh, anything you can name it, like I just mentioned healthcare or anything. So it is basically a to building an entire ecosystem and to support that other industries and ecosystem through this mobile broadband or through our mobile communication. So I will read this. Just we have already much talked about this. Why 5G was designed and what was the industry expectation from the 5G? Because from the individual perspective, it is not possible to evolve such. So industry should be ready, and for readiness, there should be some business case or some revenue generating market. So there should be some thoughts how it is going to benefit the our ecosystem or our market or our business arena. So like I have mentioned, 5G era commenced full form from 2020, and it has created the huge opportunities for consumer enterprises, operators, vendors, and many other stakeholders. And there are basically five major goals that has been defined by the IMT. That if the fully functional 5G is there, it should fulfill below five criteria. So it should deliver a sustainable network economics and innovation. Here, innovation means not just in a manner of mobile communication technology, but through the sensors, through the other electronic gadgets, or any other industry devices which are laced with the sensor and electronics subparts, and provides the boundless connectivity for all. As I earlier mentioned that in 4G we have some limitation how many devices we can connect at a time to the network. So in 5G we are exploring that idea that there should be no physically there should be no foundation to connect any number of devices. So we can say tenth of thousand of devices in a area of 1 square kilometer or something. Then transform the mobile broadband experience. So this is the common problem that even if we are telling that currently we are having a 4G, but still we are having a bad internet experience and bad customer experience. So 5G is basically aimed to eliminate those possibilities and having a good customer internet access, in short, good broadband experience. Then the one major thing is drive growth in new use cases for massive MIMO and critical IoT. Here IoT stands for Internet of Things. So anything that is connected to internet and we can connect to through internet, devices or person or offices, that comes under this arena, Internet of Things. Then accelerate the digital transformation of industry vertical. So I'm just reiterating what does it mean industry vertical. That is not just limited to the mobile telecom operators. It is from the vertical. Any industry can latch over this robust infrastructure, whether it is a healthcare or it is a food or it is a logistic or any industry. It is a railway or anything. So that is the prime goal, that anyone should come on board with this technology. So in this slide, just have a look for few seconds. I'm not speaking anything on these slides. It is self-explanatory that how the 5G journey has started and what is the forecasting. So it is the basis of the data from the GSMA by 2020. So we do not have a much forecasting about 2025. So as you can see that by 2025, almost 6 billion devices or 6 billion users are supposed to be on this technology. So the growth or the scope is very good, and sooner or later we have to adopt it, and we have to migrate on this technology. So some basic comparison of 4G versus 5G. So I will just read out here also in my discussion, some of the things I already mentioned that 4G has a limitation of supporting less devices per unit area, while 5G is much capacity. Like here it is mentioned 1 million connected devices per square meter. And when I say connected device, it could be anything. It could be a person to network, machine to machine, machine to person, or person to machine. It could be anything. Then speed. Obviously, 4G is having a low speed compared to 5G, where 5G's target was up to 1 Gbps, where 5G start from the 1 Gbps to up to 20 or more, 20 Gbps or more. Then third area of comparison is application. So in 4G, some application is limited, like I mentioned. We do not have a narrowband IoT kind of things, or we are not having any power grid solution, smart solutions on current 5G network. Though with the advanced 4G release version 16 or release version 17, we are trying to cover it, but yet it is beyond much reach. And then 5G, it is quite obvious. We can have a n number of application. I have already mentioned smart logistic, driverless cars, smart application, on-demand high-speed internet services, cable, video gaming, and everything. And then coverage. Uh, 4G and 5G, the basic difference on the coverage perspective is that it is a homogeneous network, 4G, while 5G will be the heterogeneous network where there is a macro cell, there is a small cell, micro cells, and there is n number of frequencies basis on the application, basis on the uses. So uh, I can say n number of uh, multiple access technology exists in a 5G. So 5G is basically an umbrella of the technologies within itself, while 4G is only a homogeneous network where only one technology can affordable and it can exist on a network. Then multiple data transfer rate. So 4G, if suppose currently some operator is providing a 20 Mbps per cell throughput, then it is a stagnant. We are stagnant on that 40 Mbps. So sometimes it is the use of resources as well, that for some of the devices, like if our mobile wants to talk to our refrigerator, or our laptop want to connect to our offices or our switching centers, then we might not require that much speed of 20 Mbps. Then there is a resource wastage. But while in 5G, but while in 5G, there is I just told that there are overlapping multiple access technologies and bands and other things. So we can use the basis on the requirement. If it is a low data rate application devices or application, then we can connect accordingly through NB-IoT. If it is a machine-to-machine communication and we want to through what it's called LTM. Basically, it is a long-term emulation machine devices. It is called. So there is some several 5 to 10 Mbps application, and obviously for 5G NR radio, new radio it is called. We can go up to several Gbps. Hello, hello, hello.
Yes, Aswin.
Uh, I think there is some network issue. Not able to change the slide. Let me reconnect again. So right now it is visible?
Yes, it is visible, Ashwin.
Okay, okay. So I'm going ahead with other slides. Uh, so what is the advantage compared to 4G in 5G? So it is a graphical representation of what we have already discussed, like where is less latency, that is around 1 millisecond. Then compared to 4G, 10 to 100 times more connected devices. Then also one major thing that I forgot to mention. Uh, Today the power consumption is one of the biggest issue, and that is wasting our natural resources. So 5G also aim to control the power usage. So the aim is to reduce the power dependency, and with the same number of energy sources, we could have a longer battery life, and the longer battery life sensors and other thing. Then 90% reduction in energy, that is also one target of 5G to achieve with this new technology. Then 1,000 times more capacity, as we discussed, from 100 Mbps to 20 Gbps or much beyond that. Then availability, of course. What is the mean of availability here? We aim to have a 99.999% availability. So you might have experience in previous technologies as well as current technologies that some of the time our network is not available there. Suppose in 24 hours, maybe for 10 minutes or 15 minutes, or in monsoon season, or in some natural calamity or winds. Some of the we are not having a network except for some of the hours. So in 5G, it is and with the long duration of battery lives and other. So almost 100% time we should ensure the connectivity with the equipments or with the connectable devices. Then 100% coverage, as we know, if we are going to the rural parts, or we are transporting from one city to another city, or we are going from any mode of transportation through railway or buses, there are some patches where we are not covered connected to the wireless network. So these are some limitation to the till generation technology like 4G. But in 5G, it might be possible it could not be 100% resolved, but the target is that everything, whether it is a mobile or any connected devices or machine or any, it should be 100% coverage and 100% connectivity. In this slide, students or even Mr. Tausif or other guests also are much aware of this topology, and some of the students in final semester or seventh semester, they have the idea of this network topology and other. They might have learned it in their curriculum. How GRAN, UTRAN, and others are base stations are connected to the external network. It is a PDN or internet. So I have just tried to recall it, and just want to set up an analogy between the different generations of technology and between the 5G. So after this session, I will share this PPT also. So if some of you are interested in the detailed study of these interfaces between the equipments or between the interfaces, then you can go and have a more depth knowledge on that. So in my introduction session, I named some of one or two institutional body like ITUR or IMT 2020. So basically, IMT 20 has defined some pre-qualified criteria that every operator, every vendor, or anyone who is having aware of 5G and want to connect or establish a 5G network, they should match these criterias to call it as a 5G. So, what are these criteria? Like, if you are setting up any network or any, whether it is a wireless or wireline also. So, when you can call it 5Gs, if it is a peak rate of 20 Gbps downlink, minimum 10 Gbps of uplink, then in an average user experience like me and you, if we are surfing from our internet, our laptop or our mobile devices, then the downlink should be 100 mbps and uplink should be 100 mbps. If it is not sufficing then requirement, you cannot call it as a 5G. Then spectral efficiency. So spectral efficiency is a very important phenomena and very good area of learning. So people who are interested in antennas or even in radio wave propagation. So basically, as the technology evolve, so basic fundamentals are same whether it is a 1G, 2G, 3G or any G. How we are achieving this higher data rates, higher bit rates due to spectral efficiency, and it is the most important contributing factor that we are able to achieve such. So spectral efficiency means that if you have a 10 megahertz bunch of bandwidth, then same bandwidth of 10 megahertz you are using in a 3G and you were able to produce a 10 Mbps. Then in 4G with the spectral efficiencies, some codecs and other things, you are able to produce four times more, around 40 Mbps. And in the same bunch of spectrum, you are able to generate much more uh, bandwidth in that upcoming 5G. So how it is achieved? It is through spectral efficiency. So these are the some figures given here. I will not read it out here. And spectral efficiency is measured in terms of bits per second per hertz. So there are several criteria. So if some multiple access technology and is not sufficing this spectral efficiency criteria, it cannot call as a 5G. Then area traffic capacity 10 Mbps per second per meter square. Then already I mentioned that latency. Theoretically, it should be around 1 millisecond, but as there are several applications in the hardware side also, hardware are divided in a user plane and control plane. So both the plane are having a different functionalities and acting accordingly. So both are having a set of requirement of latency as a different level. Like control panel may have a 20 millisecond, but user plane cannot have a more than 4 millisecond because control plane is basically operating with your authentication, uh, your data with the operator, your data sharing with other service provider. While user plane is basically the services we are experiencing, whether it is a video on demand, or it is a email surfing, or it is a voice or anything, or uh, virtual reality or augmented reality. So these are things done by user plane. So there we cannot afford much latency. So that is why the criteria is very strict here, 1 millisecond to 4 millisecond. Then connection density we already discussed, tenth of thousand of devices per kilometer. Then energy efficiency also we have discussed that there should be a longer battery life for the equipments, both in a base station sides as well as the user side. Then reliability, mobility, of course, mobility is one big area. As of 4G, some of you guys have experienced that if you are traveling through a train, high speed train like Rajdhani or Shatabdi, you might have went to a Delhi to Bhopal route. So in a night time, it is achieving almost 150 kmph. In that time, if you are having your connection call, so you must having an experience of uh, verbal fraction and not proper voice, and your internet connection got disconnected. So these are the limitation for the Optil technology. So 5G, we are expecting that should not be the bottleneck. Then, as I just spoke, mobile interruption time should be 0 millisecond. That means as soon as you got disconnected from the network, immediately without a delay of the second, you should be again reconnected or to this device automatically. Then bandwidth, of course, for so much requirement, the bandwidth should be also high, because in a lower bandwidth, this is the law of physics. With the lower, there is a limitation. You cannot achieve so many aim or so many requirement with the lower bandwidth. So obviously, in a 5G uh, spectrum, or what you call as a bandwidth, that is on a much higher side demand. Tausif, hello, hello.
Yes, Ashwin, yes.
Yeah, so I think there was some interruption. So again, I have reset. So I think it should be okay and visible to all right
Yes,
now.
it is visible. It's
Okay, okay,
visible.
cool.
Okay.
Great, great. So in this slide, I have just depicted the one picture that how in a graphical representation, how and what criteria 5G should suffice. So this is basically with the accordance of 3GPP release. Now this one is the one more new term that has came in our discussion. So 3GPP is basically a third generation participant project. So it was started around mid 90s while developing the 3G project, and then it became the standard that any equipment vendor or any operator or any person who want to evolve the technology, so they all people around the globe, industry leaders, technocrats, they meet and they set some common criteria for the new evolved technology, that what should be the requirement, what should be the technical obligations and other things. So basically 3GPP is the deliver routine body, and they cater the new ideas. They keep on updating on the older release version. So I wanted just to highlight that sometimes you guys have some time, so do visit 3GPP sites. So you should have a much more better ideas how the technology is getting evolved, and how with every release, how every 3 months or every 4 months in a wireless communication segment or in any communication segment, how the things are changing. So 3GPP releases and release versions giving the fair idea about that. So that was the only purpose to keep it here. Otherwise, the same thing is there as we have discussed in our previous slides. So, what are the key features of the 5G? Like millimeter wave expansion. So, as some of the persons might be aware that right now until 4G, we are using 700 megahertz, 1800, 2300 megahertz bands. so that you can say up to 2.3 gigahertz. But in 5G, that these bands are not sufficient because there is a huge chunk of spectrum requirement. So that can be suffice with the huge if you have a huge chunk of the spectrum available. So we have a only available bands in like sub 6 gigahertz, then 60 gigahertz, 80 gigahertz. So if we are talking the spectrum in gigahertz, so what you call it is a uh, duplexing between the two frequencies, that will also be available in a higher side. Like if we currently government give us 2300 megahertz band, then hardly we will get any 20 or 30 megahertz block. But if it start auctioning in the 60 gigahertz range or sub 6 gigahertz, then they will also have a more chunk of the bandwidth. So that is the key feature that 5G requires a huge amount of spectrum. Then frequency division duplexing on a low band. That is basically they are talking about the narrowband IoT. Then dynamic spectrum sharing. So this is one very useful feature. So being an industry, it is giving a fair idea of unused spectrum. If suppose there is a one side and there is less number of users in that side, so that natural resources, I mean spectrum or that capacity you can call it, that can be used for the different purpose. Suppose in a night time our activities are very low, so in that time, without investing much on a infrastructure part, with the same infrastructure, we can use that spectrum, and through that spectrum, that capacity for other industrial purposes. Then spectral aggregation, that is also a one key feature. That means as of now in 4G, in the latest release version, some features are supported, but it started standard LTE release version till 15. Spectrum aggregation was not possible. So spectrum aggregations means that if you have a two or three chunks of bandwidth, like 1810 to 1813 megahertz, then you have another chunk of 1870 to 1890, and in between is the other spectrum is given to some other operator. Then there was no, in other technologies it was like a waste of spectrum, or you can use it on a different segments or for the different user only. But in 5G, you can merge that 1810 to 1830 and 1800 to 17 to 1890, or whatever the numbers. In a, you can create a one virtual pipe from that. So that is one aspect and one key feature in 5G. Then standalone mode and network virtualization. Basically, standalone mode means where 5G standalone working, there should not be any overlapping or any lower level technologies working. Only 5G based radio is there. And then network virtualization, basically uh, uh, there is a single server based system, and there are set of programs and set of commands that are being written, and basis on the uplink and downlink and demand and user demand, a network is itself control and giving the resources and allocating the resources. So that is also key, one key requirement in the 5G. While until 4G or in 3G, this network administration or network operation part, that is being done by manually, or some or little bit virtualization is there. While in 5G, the aspect is it can be fragmented in a fully automated, and the network itself can take the decision and act accordingly. So network latency, while talking up to the latency, I told that we will cover this part because it is the most important, one of the most important thing, latency, because it play a huge role how the industry or other industry will leverage on this technology. So uh, well, it is mentioned here that Multi-access edge computing for mobile network is the critical component to achieve low latency in mobile networks. So what does it mean? That does mean is that your every device is so workable that it should not be dependent on the interoperable, or it should not be dependent on another element. It should work like, if you I give you an analogy of client and server. So every equipment can work as a server as well as a client. So basically, this sentence mean to say that. Then on-site space and power constraint are the real life challenges. So network latency, how we are going to achieve that? So that is one pain area. So to reach out that, the interconnectivity between the nodes or the topology should be like that, that the G node be what, or 5G NR, what the base station called in 5G. It should be connected to the external network or packet data network you call, or internet network, so that that the delay could be minimized. So basically, these are the things mentioned, that while planning or developing the network, these things should be kept on mind. So here, some key limiting factor, and with the interfaces, what are the current latencies in different technologies that has been given, like in LTE. Like in LTE, that is a CPRI, S1 interface, NG. So these are having a latency of 75 microsecond to 32.5 millisecond. While you can see here in new radio, NR is basically a 5G. In 5G, base station is called as a new radio, and short form of new radio is NR. So it is up to 5 millisecond. So that is how it is different from the previous generation LTE. This is the just an overview how the nodes are connected in 5G and 4G. The upper part is showing a LTE, what is also called as a LTE 4G. So here you can see there is one device, mobile. Mobile is connected to tower, and then tower is connected to core network. Tower means your cell site, or you can call simply as a site or baseband unit, whatever you want to call it. And then your core network is connected to it. So you can see here number of nodes in between are much, hence the latency is much. While in 5G, the network is designed in such a way, and equipment are so high level and uh, high capacity, that every G node B or NR, what we call it, it itself serve as a both core network as well as a baseband network. So it minimize the latency requirement. And here I have given some example of what are the limiting factor in latency. So as we know that different equipment, different interfaces between the electronics equipment, the network topologies. These are the contributing factor of the latency. Minimum the node, that better the latency. Uh, Minimum node in the network topology, better the latency. Similarly, minimum the distance between the two communicating devices, better the latency. So these are the some factors the network planner or person who are involved with the network planning of 5G, they should be aware of it. This slide is just a standardization roadmap according to the global standard. So I will leave it to up to you guys if you have much interest in that. So you can have a deep digging on that 5G, how it has been evolved from 2017 to 2020. And this data will be available on 3GPP sites also, as well as on a GSMA sites also, which are the international bodies for the mobile communication development. So my first slide, I said that if you are trying to achieve better capacity, high speed connectivity, good latency, then the back end or front haul or back haul, whatever you call it, it should be also robust, and it should also be supportive enough that our goal or the goal set for the technologies can be achieved. So here the rough idea, there are different technologies like how is the microwave backhaul is contributing, how the V-band antennas and V-band devices, then the devices operating in 1780 in 80 gigahertz, how they are contributing and what is their range, how they are uh, uh, giving us the leverage on a spectrum side, and whether these are the licensed or unlicensed, I mean free from government restriction or that. Of course, copper here is mentioned, but in 5G, copper has a very limited role, so it cannot suffice yet for the some of the last mile connectivity. It can be used. Then satellite. Some of you have heard about the satellite links also, but this is not also the cost-effective solution. And terrestrial link between the satellite and between the base station, that is very costly, and that frequency range is very limited. So that also cannot suffice much in a 5G backhauling option. So main things are in 5G backhauling is either a 5G is microwave or fiber optics, or this E band and V band devices. So we are running out of time. So I have given in my PT sub 5G RAN technologies. RAN basically stands for Radio Access Network. So in 5G, yet the complete standard has not standardized, and different gear vendors or equipment manufacturer or operators are having a different demands, and they are putting their system on a based on these three different RAN. So RAN is basically your broadband units from where your user equipment communicate, your mobile or your laptop or your dongle is connected. So that equipment, digital equipment, called as a RAN, radio access network. This is divided in three categories: C-RAN, vRAN, and Open RAN. And I have mentioned here is why it is called Open RAN, Virtual RAN, and Centralized RAN. You can go through it, and you will have an idea how to select it, how the operators are selecting it. So, why I have specifically given one PPT for Cloud Run, because as today's world, or in 2020 or 2021, Cloud Run is much more demand because it is providing a cost-effective solution. Basically, Cloud Run is giving you a free access to the software. I mean, there is only one or two hardwares or basis on the software configuration, you can dynamically use your resources. You can use the same hardware, same electronics resources for another site or another application. So that is why Cloud RAN is in much demand nowadays. You can go in Rakuten or some other OEMs or operators who are using this Cloud RAN technology in Japan, and you can have a much deeper idea on that. So concept of network slicing. So as I talked that 5G is much beyond the only mobile phone connectivity. So if it is more than mobile phone connectivity, and other industries are also there, so each and every devices, each and every application need to be treated separately. So how it will be treated separately? On a physical level, no, it is not possible on a physical level. You cannot provide a dedicated link to each and every individual user because there are infrastructure, spectrum, and so many limiting factors. So virtually there is a one single connectivity, all are connected to the same baseband or same RAN, but logically those are divided in a several planes, several virtual links, like you might have heard about the VPN. So like in internet, VPN is working. Similar in a radio access, this network slicing is happening. Here I have given one slide for traditional network versus 5G with NFV. NFV is network function virtualization, where network function can be decided, operated fully automatically. Here also I have given rough idea for the people who are interested in the network planning segment. So it might be useful for them that while planning the 5G, what should be the criteria for the selection of band should be like for rural the coverage is the prime thing. So one can use the sub 1 gigahertz bands for urban area where coverage and capacity both are in equal demand, like the tier 1 and tier 2 cities or some dense population areas within the town. So 1 to 6 gigahertz. Why these are the differentiation? Because higher the band, higher the chunk of bandwidth you have. So that is the prime fundamental for this network planning. Then very dense, like Mumbai or Delhi or New York or Tokyo, like these dense cities. Uh, we need a much more higher bandwidth, like 6 gigahertz, because there is not much required of coverage issue. There is a more requirement of capacity. So as higher the bandwidth, higher the spectral efficiency, and higher it the data rate and line rate. Here I will skip this some of these slides. I have given some how this 5G will work with artificial intelligence and with machine learning. So when I will share this PPT, someone who are interested, they can go to there. If they have any query or any further understanding, they can come to us. So I have given how AI is much needed in 5G. So as we have much talked about 5G, will do this, that, etc., etc. But the trade-off between that side is the complexity is much, much, much more. So it is very difficult to manage such networks and devices, such application through the manual intervention. So there is a must need of a artificial intelligence or self-driven intelligence network. So in this slide, I have tried to give us the some basic areas where AI will be needed. Hello, hello. हाँ हाँ बस पता ही so this is just for your references. I covered some of the topics for artificial intelligence, machine learning, and not giving much time. I want to show some pictures. You might have seen so many times, and if you have not seen yet, so just try to have a close look on these pictures. So these are the mobile towers. Basically, these are the infrastructures we have to install and equip our all the technologies. Like you can say one vertical antennas. These are the antennas for any technologies. It can be 4G, 5G. While the circular one is for the backhauling devices. It is a microwave devices. And in next slide, yeah. So these are some electronics equipments. These are called radio relay unit that is installed along with the antennas in outdoor premises on a tower or rooftop pole or rooftop tower. And these are the some box kind of thing. So these are the baseband unit basically put inside the indoor in 5G technology. Sorry, 4G technology. So these equipments are basically in 4G side. 5G side, as you can say, there is a single box solutions. Only antenna who can connect your user equipment or your mobile or your customer premises equipment and this box called as a 5G equipment. This is having all the functionality. It is having a core, it is having a baseband, it is having a switching capacity. Everything is embedded in a single device. So that is how it looks like one product solution. So that's it from my side. So we will sometime in future we will cover some more technical aspect. So basic purpose was to cover the superficial overview of 5G. I hope it will benefit your knowledge in some areas. So thank you. And that's it from my side. If you have any query or any feedback, you can reach to me with my email ID. I will try as much as possible in my capacity. You can also have your queries or your industry related question through Mr. Tausif also. He is good friend of mine and we are quite connected from several years. So that's it, Tausif, and thanks once again entire Parul University team for giving me this opportunity.
Okay. Thank you, Aswin. I really be thankful from bottom of my heart to Mr. Aswin for connecting with us and providing your valuable time for Parul University students. Thank you, Aswin, once again.
Thank you.
Welcome.
See you soon. Okay, bye.